So to talk through things, I want to talk about the optimal application boundaries. So where does one tool end and another tool begin? It's kind of a mouthful. So to get things started, I want to talk actually first about the modern data stack, which is something we've heard a lot about recently. I was originally going to show this and say, hey, like look at this explosion of conversation about the modern data stack through looking at Google Trends. So I looked at the Google Trends for this, and it turns out the explosion of the modern data stack doesn't even register on Google Trends. Though it's like, it's okay, it takes a lot to get here. You got to be something more mainstream, like, am I Kylie Jenner, to be able to show up on this. So we'll get there, we'll get there. But it is something that we obviously heard a lot about. So a lot of different people have talked about what this is. Sort of every one of the vendors in this space has their version of it. Sisense has written about it, Looker has written about it. Snowflake has, we at Mode have written about it. The Fivetran folks had a whole conference about it. And even the VCs are getting in the game talking about this. So there's a whole thing, even if it's not showing up on Google yet. And one of the good things about this, though, is there is a growing consensus about what this actually means. And given that all of y'all are here, I suspect that most folks generally agree with that consensus. And to kind of quickly recap what that looks like is something like this, where you have your source data coming from a bunch of different places, application data, SaaS apps, those kinds of things, loaded through an ETL tool that's now more of just an EL tool and fed into a centralized warehouse. On top of that warehouse, we put things like modeling layers or transformation tools that model that data into something cleaner. They often also introduce the kind of like business logic onto your data. So it's not just clean out messy data, but it's introducing canonical definitions of what a customer is, what an order is, revenue, those kinds of things. And so your database then serves as both a data lake for this raw data, as well as a data mart, essentially for modeled and clean data ready for analysis. Then we put some things on top of that. So we have BI tools for kind of code-free analysis that's generally available everywhere in the organization. We have analytics and data science applications designed for the richer analysis that more technical folks are typically doing. And then we have operational analytics tools that are dispatching data out to other systems. So they may be feeding them into production models, they may be feeding them into CRMs or marketing automation tools and things like that. Below this, and this is one of the things that Drew was just talking about, we want to have some sort of monitoring layer or observability layer that lets us know the health of the stack. So it provides a kind of operational awareness of what's up, what's down, how the system is functioning. And on top of it, we have kind of documentation layer. And so Drew also talked about this some too. This is where we actually see how we understand what data is actually flowing through here. So what does it mean? What is kind of the semantic meaning of this data? And so it's this kind of semantic awareness layer. And so we haven't solved all the problems here yet. And as Drew was talking about, especially these semantic and operational layers are pretty nascent. But in the other places, they're kind of starting to come together, but obviously there's still stuff to be done. And so I suspect most people here at this conference, a lot of people in this industry, not only kind of agree generally with this diagram, unless you are Drew and you draw out like a pyramid, but most of people agree that this is more or less what it looks like, and probably have actually drawn some version of it yourself. And so that where most of these conversations then go is people start to write names of tools in these boxes. So it's, Fivetran goes here, Stitch goes here, DBT here, Snowflake, Mode, whatever. All these things sort of fill these boxes. And that's actually where I want to change directions. Because the goal of this system isn't to solve these 10 distinct problems. We're not trying to build something that solves a whole bunch of different problems here. What we're actually trying to do is solve this kind of one cohesive problem. The point of all of this, and this is one of the things that Tristan was talking about yesterday, is to make us smarter as an organization. And so the boxes in these charts are useful steps to become smarter. They're useful tools to help us get there, but they aren't necessarily the end goals in themselves. And because of that, they're not necessarily the optimal boundaries between tools and vendors. Yes, they're kind of the way we like to classify things, but they don't necessarily mean that that's the tools that have to fit in those boxes. And so, for example, should I have separate tools for every box? Should I have one tool handle multiple problems? Should multiple tools handle one problem? How do we actually define the tooling that we have to fit into these boundaries? And so a couple of examples of that are things like transformation is one. So transformation clearly is something that DBT fits neatly into this box. But there are other tools that also do transformation. If you're using Looker, then there's LookML that also is a kind of transformation layer. Tableau extracts provide some sort of additional transformation. Mode has built one feature called definitions that is a kind of transformation and modeling layer. How should we consider those pieces when they're not in that transformation box, but they are things that are done that would fit the definition of what we would define as transformation? Similarly, operational applications, so tools like Census also have kind of query layers where you can extend the data that's already in your warehouse and transform it further. How do we think about those pieces? Another part of this is observability. This is one of the things that Drew was just talking about. Like, do we consider observability to be the responsibility of a separate application? Should we have kind of an observability application that monitors the health of the whole stack? Is it something that we should actually just lean on the warehouse for doing it? The warehouse kind of serves as the central hub in a lot of cases. Is the warehouse responsible for observability? Do we rely on the observability of every individual tool? Like, should we be looking at information across these different tools to understand how the system is behaving? And so, like, in other words, this diagram maps out these problems, but the question I really want to ask is, what are the optimal boundaries for different tools? Like, where should one tool end and another tool begin? And so the like very serious answer to this question is probably it depends. It depends on the problems you want to solve. It depends on the systems that you have in place. It depends on kind of the underlying tools you've got and who's consuming it, which this is probably true. It is, however, a fairly unhelpful answer if you're trying to build this stuff. And it's also a fairly boring answer. So instead of stealing an answer from this old white guy, I want to steal it from this old white guy. And so this is an economist named Robert Mundell. So this is my contribution to the liberal arts data conference that Drew and Tristan are establishing here. So Robert Mundell is an economist in the 1960s. He wrote a famous paper that was called The Theory of Optimal Currency Areas. And it's a set of criteria designed to assess like why it makes sense for some regions to share a currency and not others. So for instance, why should California and New York use the same currency? And why should France and Spain use the same currency, but the US and Mexico don't? And so he put together this theory, which is defining like why we have those relationships. And so it's a theory around where we should draw currency boundaries around the world. And so I want to propose something similar, which is these are sort of my theory for what are the optimal application boundaries within this modern data stack? Where should we draw boundaries between one tool and another? And so before getting to that, the last kind of caveat I'll add to this is strictly obviously for the modern data stack. If you are an engineer, I am not a web developer or an application engineer in any sort of true sense. I am not attempting to say how you should build generalized applications, but in the diagram that we just saw, this is where I think we should think about sort of tooling boundaries. So the first one, all-in-one is a myth. This is something that Drew touched on a little bit. I think this was in his Renaissance phase or maybe his prehistoric phase. That this is something that's fortunately not that controversial anymore, but I do think it's worth noting and mentioning why. It was something that folks kind of chased for a while, like, hey, we have one tool that handles everything. This is a myth because the system is now too complicated for one application. This diagram is a relative simplification of the things that people are trying to do. There's a diagram that was in the Andreessen post that I referenced earlier that describes this in a little bit more detail. This is a better representation of what's happening, but it's still not everything. And so this is like the surface of this application of all the things you're trying to do here is way too big for one application or one vendor to handle, at least until Salesforce buys us all, which they may be trying to do. And so the other part of this, though, is these pieces are evolving very quickly. That we aren't going from sort of like Drew's history, obviously, is over a very, very long period of time. That's all happened in a relatively short period of time. And so to kind of illustrate this, if you think about the companies that we talk about today, the sort of technologies that have changed, that have sort of pushed the evolution as Drew described, a lot of these companies were started between 2010 and 2016 or so. And so this is a chart of the number of data companies that YC has funded over the last decade. The spike has happened after that. There's been a big increase in the number of data companies coming after kind of this first wave of kind of transformative companies. And so those companies will produce some more transformative technologies. There will be things that come out of that we all want to adapt into our stacks. And so if we have a one-size-fits-all tool or a one kind of all-in-one application, then we're not going to be able to adapt those technologies. The second criteria I want to talk about is that transformation and consumption layers should be independent. And so I want to talk about this one for a bit longer. I think this is a particularly important one and one that's a little bit harder to explain. So to explain why this is, I want to focus on this part of the diagram. And so modeling layers, the DBT or whatever else you're using, work because they serve as this kind of canonical definition of your business logic. They define who we count as a customer, who we report on as revenue, what's an active user, all these things that are like the ways that we understand our business. They define what that stuff means. If your modeling layer ends up being only consumed by a subset of your application, so say for instance, you have a modeling layer attached to a BI tool or on top of your operational analytics tools, then it starts to undo the value of that entire thing. And to explain why, I want to kind of walk through a simple example, which I'm sure is something similar to what lots of experienced, which is suppose that you're a company and you have some Silicon Valley VC comes along and asks you like, hey, what is your trial conversion rate for prospects? Trial conversions are relatively difficult to calculate. There's a lot of complexity that goes into that for anybody who's ever done it before. What is a trial? Isn't that easy to define? There are things about, what happens if a trial is long running and somebody just left it on? Are customers that become customers without going through a trial count? So it's something you've probably introduced some logic into your modeling layer. And suppose you've done that in a way that's only accessible through your BI tool. Initially, okay, fine, that works out well. You've done that right. You could probably answer this question that this VC is asking pretty quickly, saying, hey, this is our trial conversion rate. And if you look at this, like the obvious next question you get is, and the next question that some VC may ask you is, okay, why is this happening? Like, why is our trial conversion rate falling off a cliff? Like, what do we want to do about it? To answer this question, this is often the role of data science. Like, that's the whole point of the data science or analytics function, is to answer these hard questions that aren't things that you can easily sort of like dashboard your way to. The problem here, though, is that the logic for defines what is a trial lives in your BI tool. And ideally, you would do something like this, where you're accessing that transformation logic in your analytics workflows. But this isn't possible because of the construct of this architecture. The other option you have is you can like run that through the BI tool, and you can extract data through your BI like logic layer in your analytics applications. And if you do this, like this actually doesn't really work either, because the point of the analytics function is to be able to answer questions flexibly and dynamically on top of novel questions that you haven't thought about pre-modeling before. You want to be able to combine the modeled work that you've done with data that's kind of closer to bare metal, because that's often how you actually get to the bottom of these more complicated questions. So going through kind of a standardized BI layer doesn't work there either. So what you end up happening is you end up kind of recreating that logic for your new analysis. That the analyst that's trying to do this probably tries to replicate some of the logic around what is a trial, because that doesn't exist in a tool that's accessible to the data science applications they want. So now you figure this out, you say, okay, the problem really is that we need to talk to customers more during the trial, that they're not engaging with us, we're not engaging with them in the middle of the trial. And so at this point, the VC probably comes along and says, now the real work begins. But the person in marketing comes along and says, okay, let's automate some emails. Let's have more in-product chats. Let's engage with our customers in the middle of the trial to solve this problem. And so if you do that, you now have to actually start sending out sort of emails to people through your operational analytics tools. And because of the problems we had before, you run into this problem a third time, that you don't actually know what a trial is because it's not accessible through the transformation layers. So you created a third time, that you create another sort of transformation that defines what a trial is for this layer. And at this point, the problem is pretty obvious, that you've got the same logic in three places. You're defining one definition, you're tracking one definition of trials, you're analyzing another definition, and you're sending emails to a third. And so even if you get all these definitions right, which isn't that easy, as the business changes or as the needs of the business change, these things risk diverging. And so the more you can get rid of these things and replace them with something like this, the better off you'll be. Now, I do want to make one last point here, which this isn't strictly an endorsement of dbt or in-database transformation layers. I'm certainly a big fan of dbt and the things that they do. It is possible to solve this problem through something like this, where you have a more ephemeral layer that exists outside of a database, but is agnostic to the tool that consumes it. I have thoughts on this and a whole other rant that I'll spare you from, but you could do this in a different way. dbt right now is just the best option that we've got. Okay, third criterion. You should marry BI and analytics and data science as tightly as possible. And so this gets a little bit another point that Drew was making around like the fuzziness between some of these tools. And one of the reasons why this is important is because of this question. Because every dashboard that you show, every trial conversion rate chart that you present to a VC or to whoever else will create more questions than it answers. And these dashboards often serve as a starting point, not an ending point for your analysis. And so that makes it increasingly hard to define where like BI ends and analytics or data science begins. And there's actually a trend that we're seeing more and more, and it's not just at smaller startups or companies that sort of are the forward-thinking folks. Even people like Gartner, who analyzes kind of bigger enterprises and the trends happening in Fortune 500, is seeing the same pattern, where what they say, the way they put it is the worlds between data science and BI are colliding, and that there's no clear delineation between reporting and diagnostic and predictive analysis. Like these things don't all exist in a continuum. They sort of swirl together where we do one and move to another and then move back to the previous thing we defined as reporting. So as they put it, we need to be able to move smoothly from one analytic capability to the other. And if you have too many barriers between your tools where you have to jump between a BI application and a data science application, this kind of inevitable swirling is way harder. So fourth criterion, semantic layers have to be aware of how data is consumed. And so when I talk about this, when we think of a semantic layer, we often think of things like data dictionaries or data documentation, where everything is nice and neat and understandable. And we all kind of dream of building something like this that is your perfect way to go and look everything up and it's all clean and perfect and everything is well documented. This is a lie. Like, for those of you who tried it, you know it, this ain't happening. You're not going to be able to build this as cleanly as you want. And the reason for that is, one, there's just way too much stuff to document. That the average Mode customer has over 38,000 columns in their data warehouses across 1,600 tables. That's way too much for people to document, and you really probably don't want to. A lot of that stuff is not actually useful to most people who are consuming it. And so that's like a really big challenge to undertake and try to document manually. The second part is this actually changes all the time. So across those same customers, their schemas are changing on average every 5.5 hours. And so we have to keep up with that pace of change. That's also something that makes this unworkable. So the only real workable solution around building data discovery is to build data discovery on top of how data is already consumed. You want to follow the patterns of what people are doing and let the popularity that they're demonstrating from that data drive the way that you push more people to discover data. And so what this looks like in practice is that data dictionary tools need to be integrated with BI and data science tools, that these points of consumption. They don't have to exist in the same tool. You don't need to have like your data dictionary be your BI tool, but they need to be able to have information flow from one to the other. Otherwise, the data documentation will never stay up to date with how it's actually used in practice. So the fifth and final criterion I want to bring up is that component level observability for now is probably good enough. So this might be something that's controversial for the panel that's about to happen, but we also have this kind of like vision of us wanting to create this system-wide control tower that can trace data as it moves from one end of the stack to the other. We want to have this perfect visibility in everything that's happening. I get the dream, but this is really hard to build. And the truth is, for most of us, it's probably not necessary yet. That we have observability from different tools. So we have observability from dbt and Stitch and Fivetran, as you see in these emails. And most of this stuff is reasonably self-correcting. So we can solve these problems. And if we solve them, then the ETL tools can reload the data from the source. dbt models can be set to run on full refreshes. BI tools can recompute data off of refreshed data. The system isn't that fragile in most cases. And so if it breaks, it does have downstream effects. We can usually fix it without that much of a headache. So a complete coordination here would be great. But for the time being, the system has been built in a robust enough way that we actually probably solve these problems fairly well. The one caveat to this, though, the one asterisk is this, that we can't undo these decisions. If we send emails based on the data that we have, we can't actually undo those. And so we need to be able to get this stuff right because we can't send stuff on bad data here. And so this leads kind of the caveat, which is the consumption layer needs to know if something has gone wrong. The BI tools, analytics tools, data science tools, if they're using broken data, people got to know. And so, in other words, you got to have a check engine light on your dashboard that all this work you've done before is only valuable if the people who get in the car when they drive it know that something is broken if something is broken. And so the kind of last thing I want to wrap up here with is that we're working on this, building this with dbt. That both in dbt, if you're using dbt Cloud and Mode, we'll soon be able to integrate these two products so you can actually see that check engine dash light directly in Mode. And so this is the kind of in-context data that Drew was just talking about. So I'll close up with showing a quick video of this. I know we're right at time. And so I will show a quick overview of this and then wrap things up. So what you're seeing here is a quick screencast of Mode. Within Mode, this is a standard dashboard. You'll soon be able to click on an icon here that will show you not only when the data was last run in Mode, but also when the source data was refreshed from dbt. And so this will show, if the dashboard was updated an hour ago, you can actually see that the source data is still 4 hours old. And you can actually drill into this and get a little more underlying information that's not just about the specific, like that when the load was run, but also when each individual table was run. Node will automatically parse out the queries or the tables that are used in your queries, identify which dbt models those are related to, and then present that data to you in this sort of way. And so this is exactly the thing, again, that Drew was talking about, looking for that kind of immediate way to surface this information in context to people who need it, when they need it, so that we're all sort of aware of the system that's happening and we're consuming this information. We're doing it in a way that is timely and up to date with what we're actually seeing. So with that, I will wrap things up. And so I know that there is the chat in dbt that I'll follow up in. If you have any other questions about this or the integration, please feel free to follow up there. But otherwise, thanks for your time.